Hey everyone, welcome to our second video about moving materials in and out of the cell through the cell membrane. This one's about osmosis. And osmosis is the diffusion of water through a selectively permeable membrane. And you'll remember, cell membranes are selectively permeable or semi-permeable, meaning they control what comes in and out. Now, osmosis happens specifically when water is moving across the membrane, not when other solute particles are moving, but when water is moving. And typically, water will move from an area where there is a low amount of solute, like a low amount of sugar or salt, to an area where there is a higher amount of solute or sugar or salt, and that will then be able to spread those particles further apart until they become more evenly distributed. But you'll notice here the sugar or salt solute molecules are not moving, but the water is. So over time, this beaker would change to look like this, and the number of solute particles did not change. Over here on the right side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And over here on the right side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of solutes on the right side or the left side didn't change. Solutes did not move in osmosis. Instead, to spread the solute out, water is actually moving. Osmosis is the diffusion of water. And water moved from this area where there was a lower concentration of solute to an area where there was a higher concentration of solute to try to spread those solute particles out. Here's just another picture of this happening. This is actually called a U-tube, which is funny. But see over here, you have not very many solute molecules, low concentration of solute, high concentration of solute. And what will happen is through the semi-permeable membrane, like a cell membrane, the water will move to the area where there is a higher concentration of solute to spread those particles out. And you can see that that happened here over time. Did the solute particles move? No. Did the water molecules move? Yes. Osmosis is the diffusion of water. You need to know a couple of important words when you're doing problems that involve any type of osmosis situation. Those words are hypotonic, isotonic, and hypertonic. So, hypotonic. Think about where you've heard hypo before. Have you heard of hypothermia? That's when your temperature is below what it's supposed to be. You're really cold. So, hypotonic means the solution has a low solute concentration. Look here, you can see this is a hypotonic solution. There is a relatively low concentration of solute in the solution here in this picture, so it is considered hypotonic solution. Isotonic is when the concentration is the same inside of a cell and outside of a cell, or in the solution and in the cell. If the concentration is the same, we use the word isotonic. So iso means same. Finally, we have hypertonic, and hyper, you've heard of that, like when you're hyper or excited, you have a high amount of energy. Hypertonic is when there's a high amount of solute in the solution or in the cell. And so this would be considered a hypertonic solution because look how many solute particles are out in that solution. There are a lot of solute particles. So again, hypotonic is a low concentration of solute. Isotonic is when it's about the same between the solution and the cell. And hypertonic is when there's a higher concentration of solute. How does that really work? Why does that mean anything? Well, you're going to see that if the inside of the cell is hypotonic and the outside of the cell is hypertonic, so hypo here because it's low, hyper because it's higher, water will always move to where it's hypertonic. And if you're talking about our body cells, what would happen is that if there was a high concentration of solutes in your bloodstream and a lower concentration of solutes in your blood cells that are in your bloodstream, then the water would leave from your cells and go out into the bloodstream to try to move those solute or salt particles apart, and that would cause your cells to shrivel up. If the conditions are isotonic, meaning that inside of the cell has an equal concentration of sugars or salts as outside of your cell will just stay the same. Does that mean that water won't move at all? No. Water will still move back and forth in and out of the cell, but it moves at an equal rate into and out of the cell because it's at equilibrium. Hypotonic would be when, let's say, the inside of your cell has a lot higher concentration of solute. The inside of your cell here is hypertonic. The outside of your cell, like in your bloodstream, is hypotonic. And what happens is the water all rushes into your cell to try to spread those sugar or salt molecules apart. And when the water rushes into your cell, it causes your cell to swell up and could possibly burst. All right. When you're doing a discussion for this week and in general, you might come across some osmosis beaker problems. And in these problems, they give you a beaker where they tell you the concentration of solute, maybe how much water there is. And they say there's a cell in there. That cell is represented by this shape, and that has a certain concentration. And so, what you have to decide here is the solution, the area out in the beaker, hypertonic or hypotonic or isotonic? Is the cell concentration hypertonic, hypotonic, or isotonic? And what will happen with water? Will it move into or out of the cell, and why? So, let's kind of go through this one. If we're looking at the solution, and when we're doing these problems, we disregard water. We actually don't really care what the concentration of water is. So get that out of your mind. Think about the solute. What is the concentration of solute? Because where water will move is based on the concentration of solute, like salt or sugar. In the solution, we have 10%. In the cell, we have 20% salt. So we can label these hypertonic or hypotonic based on their percentage. And 10% is low compared to 20%. So this solution where there's 10% salt would be considered hypotonic. Hypo is low. The cell had 20% salt, which is relatively high concentration of solute, and 20% is higher than 10%. And where it's higher, it's hypertonic. And so we could label that hypertonic. Now, water in this case is going to move into the cell from the beaker into the cell because water always moves to hypertonic areas where the solute concentration is higher. Thanks so much for listening. I hope this helped you understand osmosis.